So basically what's going to happen is I'm going to do a little kind of workout. I don't know, maybe a few push-ups, maybe some sit-ups. I don't know, we'll see what happens. And during that time, Jordan is actually going to explain to you what we designed here and like kind of the application and some possible uses for it. So here you go, Jordan.
Hi, I'm Jordan Suhr, and I'd like to explain the interactive max patch I Heart Sound, developed by Lance Tipton and myself at Expression College for Digital Arts. The premise of our project was to make a more interactive music listening experience based on the biofeedback of the participant. The patch we created uses the user's own heartbeat to control the tempo and instrumentation of music while working out at the gym.
So Lance has a heart monitor strapped to his chest right now, which is wirelessly transmitting his heart rate to an iPhone here, which we have hooked up to the computer.
First off, to use the program, you'll need to wear a heart rate monitor, either a more traditional wristband or a heart rate monitoring iPhone app. For demonstration purposes, we made a fake heart rate in lieu of someone actually working out. iHeart Sound is designed to catch incoming audio signals from the heart rate monitor and convert them into bangs that we can use. Let's go under the hood to see how this happens. Up here in the top left, you have your incoming audio signal, or in our case, our fake heartbeat. Next, we compensate for any errors in the monitoring device by finding an average of the last 10 incoming bangs. This is a script to find the running average so that the tempo isn't changing too sporadically. In addition to providing interactive music, iHeart Sound is also designed to be a training device to help maintain your target heart rate while exercising. You can input the target heart rate you wish to achieve based on the type of workout you're doing in this top number field. This input gets compared to your monitored and averaged heart rate to determine whether you are underperforming or overperforming. The degree to which you are exceeding or falling short of your target heart rate is captured here as what we call the correcting value. A positive value here means that your heart rate is slower than your target, whereas a negative value means your heart is going too fast. This value, positive or negative, is then compared with your current heart rate to produce a final corrected tempo for your music. We chose to produce the music in Logic Pro and are sending two values over to it. The first is the corrected tempo, which feeds straight into Logic's environment from Max, as you can see here. And that goes straight to a fader for the overall project tempo. Listen for a minute to the song as I change the value of the incoming heart rate monitor tempo. When your heart beats faster, the song will get faster. Likewise, when you start to slow down, so does the song. It's also changing the background of the max patch as well. The second number being sent over is the correcting value. First, it's getting converted into a MIDI value that Logic can use. If we go back to the environment, you can see where it's coming in here, straight to a channel fader. In this case, we're changing the volume of the strings track. The closer you are to your target heart rate, the louder the solo instrument is in the mix. It's much like a game. In order to hear all the elements in the song, you have to stay as close to your target heart rate as possible. Listen again as I change our fake heart rate, and you can hear the strings track come in and out. If you get far enough from your target heart rate, you'll eventually not be able to hear the strings track at all. And as you approach your target, it will reach its loudest volume. Biofeedback is a relatively simple concept, but has far-reaching possibilities as another real-time parameter control that can be applied to any interactive medium. Thanks for watching iHeart Sound in action.